Welcome everybody, and thank you for joining us for today's webinar, Environmental Compliance, Improve Reliability and Reduce Calibrations in FGD and SCR Systems. I'm Allison Sterling, Marketing Manager at Emerson Micromotion, and I'm pleased to welcome you to the Emerson Flow Expert Series. Before we begin today, I'd like to take a moment to acquaint you with your webinar environment. On your screen, you should see a presentation window on the left side, a Q&A chat window in the upper right, a media player controls, and a resource box with some related content also on the right side, where you can view and download the content during the event. You can resize, move, or minimize any of these windows during the event to fit your viewing preferences. And at the bottom of your display, you'll see a row of icons that give you added capabilities, such as sharing the webinar via social media channels or requesting a visit from one of our Flow experts. Throughout our presentation, we encourage you to interact with our speaker by typing in questions and comments using that Q&A chat panel. We will be answering questions at the end of the event, and we will also be recording today's webinar, and we will make the link to that recording available to you after the event via email. On today's webinar, we are lucky enough to have joining us Ed Decker, a global chemical industry marketing manager at Emerson Micromotion. Ed is a global business development director for the power industry, and he has been with Emerson Process Management and with Emerson for 20 years in a variety of roles, including sales, key account management, and business development. Prior to joining Emerson, Ed sold a variety of process control instrumentation products in upstate New York. And as you can see, Ed quite enjoys the outdoors, especially fishing. Welcome, Ed.
Thank you, Allison. And thank you, everyone, for attending today's webinar. I have the privilege of visiting power generation companies around the world and have noticed there are some themes that are pretty universal as far as industry challenges. The top two, as shown in this Black and Veatch study, include concerns over improving plant reliability and increasing environmental compliance. During this webinar, we're going to discuss how new developments in smart instrumentation can improve reliability of your emissions equipment and ensure that your plant is in compliance in a cost-effective manner. As the costs and complexity of environmental compliance continue to rise, power plants are turning to a new generation of smart instrumentation to improve reliability and reduce calibration frequency. Let's face it, compliance will only get more complicated, so managing your assets in the most efficient manner will maximize availability and profitability. This time I'd like to take a short poll, and that question that I have for the audience is, what flow technology do you use in your plant? And I'll give you a minute to tick off the box for which technologies you use, and then we'll review that quickly. Okay, looks like we have a pretty good variety of different technologies that are being used out there. Interesting information. Continuing on here. There are many areas of a power plant where Emerson flow and density instrumentation products are used. This interactive schematic is available on our website, and I welcome you to explore it at your convenience. Today, I'd like to concentrate on how Emerson can help your plant meet new and existing environmental regulations, specifically in the selective catalytic reduction and flue gas desulfurization units. Let's start by taking a look at this chart of precision flow measurement technologies. As you can see, Coriolis meters are one of the fastest growing flow technologies in today's marketplace. Traditional flow measurement technologies like differential pressure have a large share but are not growing at the rate that Coriolis meters are. Let's take a look at how Coriolis technology works to see why. Let's start by looking at how Coriolis meters measure mass flow. All of our meters work in a similar way. The material to be measured enters the meter through the process connections and passes through a flow splitter that divides the material equally between the measurement tubes. 100% of the material passes through the measurement tubes. There's no slipstream inside the meter. The manifold and end connections of the meter provide a rigid structure to mount in your pipeline while isolating the measurement sections of the meter from any outside noise. The meter tubes are vibrated at their natural frequency with a low-voltage DC drive coil that you can see mounted to the tubes in the top center cutaway. With no flow, the meter tubes vibrate like you see here on top. In a Coriolis meter, the inertial force is provided by vibrating the flow tubes. Flow, moving through the tubes, tries to continue on its path perpendicular to the axis of vibration, resisting the movement. That resistance to the movement causes a deflection of the tubes in the form of tube twist. The tube twist, or angle of deflection from the vibration plane, is measured and converted into mass flow measurement. When there is flow in the Coriolis meter, the effect on the tubes twists them like you see here on the bottom. Magnet and coil assemblies called pickoffs are mounted to the flow tubes as seen in the center bottom cutaway. Each coil moves through the magnetic field of the adjacent magnet and creates a voltage in the form of a sine wave. Most implementations use a pair of counter-vibrating tubes to cancel the effect of external vibrations, but many geometries exist to meet various application requirements or to avoid patent infringement. During a no-flow condition, there is no Coriolis effect and the sine waves are in phase with each other as illustrated in the picture on the left. When fluid is moving through the sensor's tubes, as shown on the right, Coriolis forces are induced, causing the flow tubes to twist in opposition to each other. The time difference between the sine waves is measured and is called delta T, or time delay, which is directly proportional to the mass flow rate. The measurement of mass flow is very simple, as is the calibration. The flow calibration factor consists of 10 characters, including 2 decimal points. The first 5 digits are the flow calibration factor. This calibration factor multiplied by a given delta T yields mass flow rate in grams per second. So if a user wanted to shift the calibration by 10%, simple 10% change in the calibration factor is made. The last 3 digits of the calibration number are a temperature coefficient for the sensor tube material. This coefficient compensates for the effect of temperature on tube rigidity, or Young's modulus of elasticity, in percent change in rigidity per 100 degrees C. 4.74 number shown is for a stainless steel meter. A different number would be used for other metallurgies like Hastelloy C or titanium. The RTD that measures the tube temperature is plus or minus 1 degree C from the process temperature and can be configured as an output variable. Let's now look at how we measure density. Density measurement is based on the natural frequency of the system, including the flow tubes and the process fluid. As the mass increases, the natural frequency of the system decreases. As the mass decreases, the natural frequency of the system increases. Density calibration is performed at the factory on air and water. Meters are filled with air, resulting in a tube period, or K1, of 10,484 microseconds in this example. Next, the meter is filled with water, which results in a tube period, or K2, of 10,966 microseconds. Those two values, K1 and K2, are plotted against the density of the two fluids the meter is calibrated on, air and water. In this case, D1 is the density of air, and D2 is the density of water. The transmitter stores these values and automatically calculates the fluid density based on the tube period. In other words, if the tube period is 10,817 microseconds, the transmitter knows that the fluid density must be 0.6871 grams per cc to a very high degree of accuracy. Micromotion meters can perform as good as plus or minus 0.0002 grams per cc. Micromotion performs the density calibration in the factory. Field calibrations can also be performed using air, water, or virtually any other process fluid with a known density. Volumetric flow is a calculated variable derived by dividing the mass flow reading by the density of the fluid. The resulting measurement is very accurate and can be referenced to standard temperature using the secondary temperature measurement of the sensor. Examples of other benefits of using Coriolis meters to measure volumetric flow: a low pressure drop, wide turn down, high accuracy, and a high degree of linearity. As you can see on the slide, an increase in the temperature causes the density to go down, which, according to the formula we looked at in the previous slide, results in an increased volume. Therefore, the higher the temperature of a fluid or gas, the greater volume it will occupy. Notice how the units of mass stayed the same when the temperature went up. That's because mass does not change with temperature. The bucket on the left and the bucket on the right still have the same mass, even though their temperatures are different. If you're buying gas for your car by the gallon, you want to buy it at 16 degrees or at 94 degrees. I'd want to buy it at 16 degrees because I'd get more gas for my money. But if you're paying by the kilogram, you'll pay the same regardless of temperature. This is a significant reason why custody transfer with Coriolis meters is so successful. The same principle applies with pressure, mainly when talking about gas. As pressure changes, so does the density and the volume, but mass always stays the same. Because Coriolis meters measure mass directly, they're not affected by changing Reynolds numbers, flow profiles, or by turbulent, swirling, or pulsating flows. They require no straight runs of pipe, and because of this, their installations tend to be simpler and less expensive than traditional flow technologies that require straight runs of pipe, pressure and temperature compensation, and in some cases, flow straighteners. From a micromotion or Rosemount flow standpoint, Emerson has a very broad portfolio of products, from our elite high-performance products that are certified for fiscal custody transfer, all the way down to our R-Series Coriolis meters and our utility-grade vortex and magnetic flow meters. Micromotion's world-class calibration facility is accredited to an uncertainty of 0.013%. At this point, I'd like to take another quick poll of the audience. And the first question I have is an accurate lime slurry solids measurement important to your FGD operation? Everybody take a second to answer here. Okay, it looks like a majority of people, solids accuracy is important to your operation. Second question I have is, does your plant ever suffer from ammonia slip in your SCR systems? Another minute here to answer. Okay, looks like some of you folks also suffer from ammonia slip in your SCR process. Interesting information, and thank you for participating here. Let's look closer now at the selective catalytic reduction in flue gas desulfurization applications. First, I'd like to highlight the selective catalytic reduction process and its conversion of nitrogen oxide compounds. Selective catalytic reduction is a means of converting nitrogen oxides, also referred to as NOx, with the aid of a catalyst into diatomic nitrogen in water. A gaseous reductant, typically anhydrous or aqueous ammonia or urea, added to a stream of flue gas and is absorbed into a catalyst. Some of the challenges facing users of SCR technology are making sure that the ratio of reductant to catalyst is correct, the amount of flue gas being scrubbed. Since the stoichiometry or chemistry is based on mass or mole weight reaction and not volume, better to control using a direct mass flow measurement. Coriolis meters can help with mass balancing, reducing ammonia slip, and measuring the ammonia concentration all in one device. In addition, due to their design that contains no moving parts, they can improve unit reliability. Next, I would like to talk about flue gas desulfurization. Flue gas desulfurization is a set of technologies used to remove sulfur dioxide from the exhaust of flue gases of fossil fuel power plants. Today, I will be covering the wet scrubbing process using a slurry of alkaline sorbent, usually limestone or lime, to absorb the sulfur dioxide. The wet lime slurry by nature is hard to measure accurately and causes premature failure of many flow technologies. As maintaining the correct flow rate and percent solids measurement are an important part of efficient scrubbing, Emerson offers two solutions to make these measurements. First, you can use a Coriolis meter that can measure the mass flow rate and percent solids. Very tight flow control must be maintained in this method, or plugging or eroding of the tubes will result. Best practices dictate a velocity range of between 3 and 7 feet per second. If flow rate cannot be tightly controlled, a second method can be employed, using a magnetic flow meter in conjunction with a fork densitometer. These two devices will give you the desired flow rate and solids measurements needed for precise control. In addition, the low pressure drop across a magnetic flow meter reduces pumping costs in the process. Let's now look at some Emerson solutions and proven results. Here we have a proven result where mag meters and fork densitometers help save a plant money on their operating budget. This particular customer was using nuclear densitometers to measure lime slurry density. The nuclear devices required lots of paperwork, stringent safety procedures, and frequent calibration. The micromotion fork densitometers have none of these requirements and are less expensive to purchase. This and other examples can be found on our website. Micromotion meters have very good long-term stability and can reduce or eliminate unnecessary calibrations in many applications. When a measurement is important, like for fiscal custody transfer, safety, or critical process control, you want the confidence to know that your flow measurement is reading right. Emerson is focused on delivering that with our micromotion Coriolis meters through smart meter verification. We will be discussing smart meter verification next. There are various people in the plant that interface with our flow meters, from maintenance and quality to engineering and metrology. Many different areas of the plant can benefit from smart meter verification. At this point, I'd like to show a short video on what smart meter verification is and its potential benefits within your plant.
Hi, today we're going to talk about Emerson's micromotion and smart meter verification. This is Tom. Tom is a reliability engineer. His job requires him to coordinate with everyone at his plant and keep the plant running smoothly. Tom knows that his Coriolis meters are reliable. He knows that they're safe, and he knows they're accurate. But how does he prove it? Well, the way Tom proves it is harder than it should be. His applications call for proving meter accuracy at regular intervals. But pulling meters to be drained, cleaned, and shipped to a lab means Tom has to interrupt his process and reduce production. In addition, removing meters increases the risks of damage during transit, and there's no guarantee the meter's performance will improve. To combat that, there have been pretty inventive ways to verify and calibrate meters on-site or in the lab, like catch and weigh tests done with a bucket on a scale, the use of master meters and portable provers, or even gauging the tank level against an old strapping table. When you're trying to calibrate a meter with 0.1% accuracy, these techniques might not stand up to an audit. Last year alone, Tom and his team spent $300,000 performing calibration checks just to prove something that Tom already knew. The meters hadn't changed. Micromotion has a better way. We call it Smart Meter Verification, or SMV. SMV is the only in-situ, on-demand diagnostic system that tests the entire meter, verifying meter health, flow tube integrity, and electronics, all without having to interrupt the process. SMV ensures that the meter is operating as well as the day it left the factory. It's like having a virtual calibration stand built into every flow meter in your system. With SMV, Tom can verify his meter in 90 seconds or less. SMV cuts the cost of calibration improving because Tom can run it more often within his plant. Tom can even run SMV daily to provide a robust audit trail or use SMV to bolster measurement confidence. SMV also creates a safer work environment. It can run remotely, which is a huge advantage in harsh conditions or dangerous applications. With SMV, Tom captures the data he needs. Plus, he gets verification reports, making it easier to comply with third-party agency requirements. And he can manage his process better and reach peak efficiency. SMV delivers the measurement confidence you need at a cost that improves your productivity, all while keeping your employees safe. To learn more about SMV and micromotion Coriolis meters, visit www.micromotion.com/SMV.
With Emerson as your measurement partner, we can help you reduce the costs associated with meeting new environmental regulations and improve plant availability, reduce energy costs, and ensure safety. We have helped many power generation customers in these areas, and we would love to help you as well. The combination of innovative technologies and field experience, we look forward to helping you improve your bottom line. Micromotion smart meter verification is recognized by the U.S. EPA as a way to meet 40 CFR Part 98 of the Clean Air Act while extending calibrations. In addition, the EPA is currently evaluating smart meter verification technology to extend calibration intervals in other parts of the 40 CFR statutes, like 40 CFR Part 75. Some users have saved up to $300,000 per year on reduced or eliminated calibrations. There are a number of third-party organizations that currently accept or are evaluating our smart meter verification for acceptance. I'd like to ask another poll question at this point, and that is, what is the timeline for upgrading your environmental emissions equipment in your plant? Give a quick minute to answer here, and take a look at the answers. Okay, looks like we have quite a breadth of responses here, everything from less than 6 months to more than 2 years out. And once again, I appreciate everyone's participation in the polls here. For additional information, feel free to contact me at ed.decker@emerson.com or click on the URL that we have here. Thanks for attending this webinar. At this time, we will take a few questions. Please remember that if we don't have time to get to your question, you can use our Contact Me form to access follow-up assistance. Thank you again for your time and attention.
And as a reminder, as I just mentioned, and thanks again, Ed, so much for all this great information, please don't hesitate to start typing in your questions into that Q&A panel. We will answer as many as we can right now, and if we can't get to your question, we'll certainly follow up you via email. And if you think of it after the fact, as Ed mentioned, we have the Contact Us widget there at the bottom of your screen, so you're always welcome to email Ed or our Flow expert with any questions you can think of. So thanks again, Ed, and it looks like we have a couple questions that already come in, Ed, so I'll hand it back over to you.
Thank you, Allison. Okay, the first question that we have, that's a pretty specific one. Are your meters certified for fiscal custody transfer in Texas? Well, the answer to that is yes, they absolutely are. We're certified for fiscal custody transfer in all 50 U.S. states as well as many countries throughout the world. And we would be happy to work with you and your organization to get set up to take advantage of our fiscal custody transfer measurements. It's always good to make sure that you're getting what you're paying for from your vendors when it comes to raw materials coming into the plant. And this is a great way to do that. And look, we have another question coming in here. How well do Coriolis meters work on ammonia flows? Well, actually, we work quite well on ammonia flows, both aqueous and anhydrous ammonia flows. We have the added benefit of not only being able to do direct mass flow measurement of the ammonia flows, as in an SCR scenario, but we can also give you the exact percent concentration of the ammonia to a very accurate value. See some other getting typed in here. Okay. How robust is your lime slurry solids measurement, and how many do you have installed in the field? Another great question. as we looked at in the webinar, we have two distinct solutions for lime slurry measurement. From a solids measurement standpoint, we can once again do that by a Coriolis meter to do percent solids, or we can also do it by a fork densitometer. Both ways are quite accurate and can help you to make sure that your FGD system is running as efficiently as possible. Any more questions from the audience here? Please feel free to type away. Okay, one more question here. When do we expect our meters to be approved for 40 CFR Part 75 applications? Another great question. EPA approved our meters in smart meter verification for use in Part 98 of the Clean Air Statutes a number of years ago. They move a little bit slower with Part 75 of the Clean Air Act, but we've had our technology in front of them for a couple of years now. And as a matter of fact, we have a number of customers that have gotten the installations approved basically by exception on one-offs by taking documentation with the help of Micromotion, presenting it to the EPA, and getting it approved for Part 75. But we do expect blanket approval for Part 75 applications sometime in the next 12 months. Any other questions out there?
And just a reminder to everybody, if you think of something afterwards, don't hesitate to email Ed, or you can use the purple contact us widget there at the bottom, which will email our team of flow experts. So don't hesitate to reach out to us. And it looks like I think we're at the end of our questions. So I want to thank everybody for joining us today and for all the great questions that we got in. Just as a reminder, we will be sending out a link to this recording tomorrow via email, as well as providing you with some additional resources about how you can help improve the reliability and reduce calibration in your FGD and SCR systems. On behalf of our guest, Ed Decker, as well as everyone at Emerson Micromotion, we thank everybody for joining us and taking the time to view our webinar, and we hope that you have an outstanding day. Thank you.